lattice. So integer lattice is the set of all points in the Cartesian plane for which both x and y coordinates are integers. So suppose this is the point 2 comma 4. So what will be this? This will be x 3, right, because we move the x-axis, right, but we haven't moved along the y, so this will be 3 comma 4, right, this will be 4 comma 4. Now here we didn't move the x-axis, so this will be 2, but we moved the y, so this will be 2 comma 5. Similarly this will be 3 comma 5, and so on, so right. So what is the important is that both the x and the y coordinates are the integer, right. So 2.5 comma 8 won't be a part, right. So moving ahead, so let's say this is my starting point, okay. So this is my start point, right, and I want to reach over here, which is my end point, okay. So what is the lattice path? The lattice path is one of the shortest possible path connecting the 2 points on the lattice, okay. So if I want to reach from start to end, what I can do, I go this way, then over here, then here, and then over here. This could be one of the possible lattice path, right, because I reach from start point to end point with minimum number of steps. Now the one thing that we can feel is that, is there any other path which is having even shorter length than this? So the answer is no, because see, no matter which path you choose, you, in anyhow given condition, you will have to go from this x coordinate to this x coordinate, means you will always have to move 2 steps along the x axis, right. Similarly, no matter what happens, we will always have to move from this starting y coordinate to the end y coordinate, right. So how many steps are there? There are total 3 steps along the y axis. So no matter what we do, we will always have to move the 2 steps across the x axis, right, and 3 steps across the y axis in the forward direction in order to reach our second point, right. So we will always need the 5 steps in total, right. So how can I write that? I will always need 2 steps along the x axis, right, and 3 steps along the y axis, thereby total 5 steps, okay. I hope you have got this idea. So now my question is, how many lattice paths are there in order to reach from start to end, okay. So if you want to think, pause the video, give it some thought, it's fine. Even if you spend an hour, that's fine. It's, if you come up with your own logic, it would be really great, right. Also one more thing, no matter what you do, if you want to find the shortest path, you are having only 2 choices in order to move from start to end. Either you will go to the left side or you will go upward. You will never go to the left, right, otherwise you will be wasting your steps, okay. So I guess this is the easy part to understand, but I just thought I should clarify this. So now let's think towards the solution, okay. So how many paths are there total? See, as we just saw, no matter what happen, I will always have to take the 5 steps, right. Now if you have watched the previous video, where the one problem we saw was related to the substrings, right, or the subsets, you can say. So there we saw the number of strings of the number of sets of 3 elements we got by the logic of phi c3. Now how this relates over here? So let's think in that direction, okay. Yeah. So if I want to reach my target node, okay, just give me a second. So yeah, that will make easier. Yeah. So now if I have to take the 5 steps and I know that among those 5 steps, two will be definitely across the x-axis, as I will always, no matter what happens, I will have to move from this x coordinate to this x coordinate, right? And 3 will be definitely across the y-axis, because no matter what happens, I will have to cover this height, right? I will have to cover this height, which is of a 3 length, 3 units to be precise, okay? So what we can think of, how can we reach over there? So one approach could be that we will be just walking around the borders of our grid, like from here and then from here to over here. Forgive me for my drawing. Okay, so this is the one of the way. Or what we can do is that first we will go across the y-axis 3 steps, and then we will move across the x-axis 2 steps. Or what else could be our approach? We can do is like that, we will move 1 step across the x-axis, then the 2 steps across the y, then one more step across the x. So please keep this thing in mind, that we have achieved our target of taking 2 steps in the right direction. Now what we left with, we are at this position, okay? We are at this position, and still we have just covered only 2 steps along the y, and we need to cover one more step along the y axis, and this is that step, isn't it? Right? So what one thing we noticed is that no matter what happens, we will always have to take the 2 steps across the x-axis and 3 steps across the y-axis. Okay, so let's see this, how can we represent this? Okay, so 3 steps across the y. So I am having total 5 steps: step 1, step 2, step 3, step 4, and step 5. My target is to take 2 steps in the right direction or the x direction, and 3 steps across the up direction or y direction, y axis. Okay, so no matter what I places I choose, I will always reach to my end node if I choose any two position among these 5 position for my right direction. Okay, so which two position I can choose amongst the 5 position? I need to choose only two position. For what? For the right direction. Now suppose I choose the step number 3 and 5 for the right, so automatically I will be left with exactly 3 places, and now those 3 places will definitely contain the up direction. Okay, no doubt there. Okay, right? Because out of 5 places, if I am choosing 2 places for the right direction, obviously I will be left with 3 places, and I also, and at the same time I also want to take the 3 places upward, so those 3 places will be filled up with the up sign. So how, what could be the other way to look at this? See, these are our 5 positions. Okay, 5 position or the 5 steps we want to take. Now, the other might say, out of 5, I want to choose 3 positions as an upward position. So let's say he choose this one, and this one. These are the 3 positions which are upward, right? Now, if he chooses the 3 positions upward, and these are the 1, 2, and 4, now obviously we are remaining with the again 2 steps, okay? And we have to also take the 2 steps in the rightward direction. So what choices do we have? We will have to take right move over here. So no matter if you write 5c2 or 5c3, you will be getting same answer, right? Now this is another way to look at the formula. The many people will write nck will be equal to nc n minus k. Why is it so? See, we will see one more time. Okay, if I am having n places, okay, and I am choosing k of them, so obviously I will be remaining with n minus k, right? So what places I left? I left with this, and this. What other person might say? I have been given these places, okay, and I will reject. Which places I will reject? I will reject these 3 places. Okay. uh, Sorry, I messed up with the drawing. Okay, so automatically I'm left with again these three positions. Okay, so what this formula intuitively tells us, out of n you are choosing k. Okay, here you are choosing k, which is as good as you are rejecting n minus k, and both things are logically same, right? If out of n things you are choosing k things, it's as good as you have rejected n minus k things out of n, right? Is it making sense now? Okay, so this is the intuition behind this formula. Okay, so please keep this thing in mind. Okay, now let's get back to a problem. So, as we saw, no matter what we choose, we always have to take the two right and three up steps, and those can be placed anywhere in the total of five steps. So, let's see this combination, how this is working. So, what this say? First, we will move first step in upward direction. Okay, second step is also in upward direction. Third step is in rightmost direction. Fourth step is in upward direction, and fifth step is again rightmost. See, so this is one of the way, right? I hope you have got this idea. Now let's look at it, this as per our algorithms way. Okay, this is even more fun. Yeah, okay, we got it. Okay. Now, you guys tell me, suppose this is as usual our uh, end point. Okay. This is our start point. So, let me say this is our point A. Okay. This is point A. This is point B. Now, you tell me how, if I want to reach E, if if you want to reach endpoint E, okay, is it possible that you will go or you will reach E without going through either A or B? No, it's never possible, right? Either we will go through A or we will go through B. Is it making sense now? Either we will go through A or we will go through B. Okay, one of these things will definitely happen, and exactly one of them will happen. It won't happen that we are going through both A and B. It's not possible, right? So if you notice carefully, no matter what happen, if you want to reach E, you are having only two options: either come from A or come from B. So what I can say you, the total number of paths, the number of lattice paths, okay, for point E is equals to total number of lattice paths for point A plus I am adding addition. The fundamental principle of addition. Both of the points are disjoint. It will never happen that a single path is containing both A and B. That's why we can use the fundamental principle of addition, as both of them are disjoint and nothing is in common between them. So number of lattice paths for the point B. Okay, I hope this is clear to you now why I can say that. Okay, now if you are from computer science background, you can easily say that this is the recurrence relation. Okay, recurrence relation for path, for number of paths to reach to the point E starting from the point S. Okay, now if this is the recurrence relation, we will know now there will be many overlapping sub problems, and this give birth to the dynamic programming approach to solve the problem, right? So I hope I have been I have been successful in my attempt to clear the many dots that you had. If you know anything better intuitive understanding or better approach to tell this, please do write on in that in comment session so that others can learn too, and I